All right. This is the last Unit 8 assignment that I could see, Lesson 4. It's about linear equations and inequalities in two variables. Two variables means two things can change. So for example, we've got friends going to the movie. We can buy boxes of candy, right? Or you can buy a combo, a medium drink and popcorn. So you can buy candy or the drink and popcorn combo. And there's a bunch of people, so we might buy multiple candies and multiple popcorn combos. However, how many are we going to buy? Well, we need to come up with a way to represent that. So a way we might represent how many candies we're buying is $2, $2 times the number of candies I buy. So let's make that X just for fun. Okay, so this could be candy, right? And then you could have $6 times the number of combos you buy. We're going to say popcorn. This file's not uploaded. Doesn't matter. Sure, it's all uploaded to Google Drive. Okay, back to here. Okay, so here's a really important thing. Some people, when they're doing stuff with multiple variables, they call them the same thing. So what we would do to find out the amount we have is this plus that, right? Here's a problem. They want us to be able to have an expression that represents the total amount you could spend on various arrangements, right? So maybe I buy one of one and two of the other, or five of one and three of the other. We're not paying the same amount of candies as popcorn combos. And there's a big important rule in math that says I can't have one number or one letter here, one variable, represent two different numbers. So if it's 2 over here, it has to be 2 over there. So if I buy 2 candies, I have to be buying 2 popcorn combos right now, the way it's written. That's not what we want. That's why we have 2 different variables, one to keep track of this. Let's call this candy. Popcorn. I'm going to change it candy and popcorn. So we have 2 different variables to say, hey, they could be different numbers from the other one. If I buy 5 candies, it doesn't mean I'm automatically buying 5 popcorns as well. And that right there is our answer. This is called an expression. Why is it an expression? Well, because it doesn't have an equal sign. If it has an equal sign, it'll be an equation. But anything else is basically an expression. Could be a number, could be a letter, could be combinations of numbers and letters. They're just all called expressions. That's what an expression is. Okay? All right. After buying stuff, you have $12 left to spend for snacks. Okay. Okay, so we're going to split these things to spend $12. Use your cost expression from the number one expression, question 1, to write an inequality that indicates you would get change for your snack bar. Oh, that's really, really charged, I think. I don't know. That does not look like a very good sentence. But here's what we're saying. I have $12 to spend on this. I can't spend $13. Sure, I can spend $10, but I can't spend any more than $12, right? So what I'm going to do is I'm going to say that 2C plus 6P, wait for it, this is how much I'm spending. This is how we buy our candy. We have $2 for the candies, $6 for the popcorn combos. But no matter what, I cannot possibly, it has to be less than or equal to 12. Because I can't spend more than $12 because I don't have more than $12. I could buy 2 popcorns and no candies. I could buy 6 candies and no popcorns. I could buy other combinations in between. Oh, they decided to do it like this. It's technically wrong. Right? Yep, that's okay. They're being sloppy, I guess. We're going to use substitution to determine if 5, 1 is a solution to this. Okay, so C has become X and P has become Y. They're still 2 different things. It's just I'm not using letters that were originally part of the problem. That's perfectly okay. Okay, so let's see. Notice the part of why they're saying that using X and Y is because points are always X Why? Always. We never put the letters in a different order. X always comes first. So let's find out if 2 times 5 plus 6 times 1 is less than 12. Well, 2 times 5 is 10, plus 6 times 1 is 6, is less than 12. In other words, 16 is less than 12. Is 16 less than 12? I think it is. It seems to me that that's true. Just going to go out on a limb and say that that doesn't make any sense. This is not a solution. They spent more money than they had. Okay? 16 is not less than 12. Okay, so that's what's going on there. That's not a solution. A solution is something that makes it work, that makes this statement true. These things have to add up to less than 12. They don't if I make x be 5 and y be 1. So that's not a solution. Anything that makes it add up to less than 12 is a solution. Use substitution to determine if buying 2 boxes of candy and 1 combo will satisfy the problem situation. Okay, let's do that. I'm just going to continue to use less than because it's easier to type, even though it should be less than or equal to. But it's okay. I can change it if we have to later. So we're going to say 2x plus 6y is less than. Okay, and now we're going to buy 2 boxes of candy. Remember, x is the candy, the first one. They cost $2. So 2 times 2 plus 1 times 6, or 6 times 1, less than 12. These line up. I like to line up my equal signs or my inequality signs. That makes 4 plus 6 less than 12. Is 4 plus 6 less than 12? Yes, 4 plus 6 is 10. 10 is less than 12. This is a solution. This combination of candy / popcorn costs less than $12. That's what we're talking about here. Okay, which of the given ordered pairs are solutions to this? Well, let's see here. If I plug a 3 in and a 2 in, 3 times 2 makes 6. 2 times 6 makes 12. 6 plus 12 is more than 12. So, oops, I'll go down here. Make this be, nope, that does not work. 0, 1. If I buy 0 candies and 1 popcorn, that's going to cost $6. That's less than 12. It's a boring order, but there you go. How about -1? Now, we've left the realm of popcorn. Obviously, we can't buy negative popcorns, but technically, if they were just dealing with numbers here and not with popcorns, then sure, I can plug in a -1. What if I have that? 9 times 2 is 18. 6 times -1 is -6. 18 minus 6 is 12. That's not less than 12. It's exactly 12. It equals 12. We want it to be less than 12. All right, let's try the next one. 6 times 2 is 12. 6 times -2 is -12. This one, you'll get 12 minus 12. That makes 0. 0 is definitely less than 12. Works. I know it doesn't make sense for candy bars, but the movie theater, but numerically it works. And that's all we really care about now that they're just saying numbers. Okay, here we have -4 times 2 is -8. And 2 times 6 is 12. -8 and 12, they add to make 4. 4 is less than 12. So that one works as well. And 5, 0. 5 times 2 is 10, plus 0 times 6 is 0. That's going to make 10. That's going to be less than 12 as well. You can plug them in and find out. These ones, the 2 numbers that they make will add to make more than 12. These 4 numbers that they add to make are less than 12. That's what we're dealing with here. Okay, now we're going to talk about graphing lines and filling in sections of a graph, basically. Okay, so we'll talk about that in a moment. We're almost to the 3rd page. Hooray. We're going to graph this line. Now, this is in standard form, right? So we're going to use standard form to graph it. I'm going to notice that if I make x be 0, what will y be? And if I make y be 0, what will x be? Those are the 2 graph points that I do when I'm in standard form. So let me really quickly make a graph. I hate making graphs on Zoom on here, but I'm sure you do too. Might as well feel your pain with you. Here we are. We got, oops, wrong button. We got fun. There. All right, so now I got my graph. Okay, so if I made the first number be 0, that'd be 2 times 0 is 0. 6 times what makes 12? How would I get 12 here? 6 times 2. This would have to be 2. That's the type of math I'm doing. Okay. So I'm going to go back in here and we're going to say, yeah, if the first number is 0, then the second one has to be 2 because 2 times 6 makes 12. Now, if the first number is 0, or if the second number is 0, I have 2 times what makes 12? 6. So also I can have 6, 0. Why is that useful to me? Because those are 2 points on the graph, on this line. Okay, and all I need are 2 points on a line to be able to graph it. So here we go. We're going to go here, grab this. We're going to graph this point. 0, 2, 0, 2. And we're going to graph this point 6, 0. 1, 2, 3, 4, 5, 6, 0. Now it's just a matter of sorry, I'm daydreaming a little. Oops, wrong button. Yeah, just like that. Okay. Once more, just remind you, these buttons, this guy's right here, and that guy's right there. That's how we graph things in standard form. Okay. So they told us to graph it. How would you modify your graph from question 6 to show all the ordered pairs that are of this that make the inequality true? Okay. This is where we're going to go. Let me there. Okay, so I want all of the things that add to make less than 12. Now, the cool thing is this line is all of the ones that add to make exactly 12, because that's what the equals sign stands for. We found all of the combinations of candy and popcorn that add to make exactly 12. They're on this line right here. I could buy 2 popcorns but no candy. I could buy a few popcorns, but some, like here we have a certain number of popcorns. Here we can buy 6 candies but no popcorns, and everything in between. Okay? Now if I have something above the line, now I have more candies and more popcorns. It's going to add to make more than 12. But if I have something below this line, like down here, I could buy 1 candy and 1 popcorn. It would cost less than 12. So anything under this line will cost less than $12. That is what we're dealing with here. And so if I've got this type of a problem, what I'm going to do is I'm just going to go to show that I want everything under the line. Now, technically, if I wanted to be really fancy, since we're talking about candy and popcorn, and I can't spend negative money, right? I could also focus on just, oops, wrong way. We could just focus on this chunk right here. That's really the only place that makes sense for popcorn and candy. We don't sell negative popcorn and sell negative candy and pay negative dollars. That doesn't make any sense. So unless you like selling candy and popcorn, if you go to the movie theater and sell popcorn and candy all the time, don't try it, you'll get in trouble. Okay, but the point is we fill in everything below the line, and that's all of the things that add to less than 12. All of the combinations of x and y that add to less than 12 when you put them in. Right, inequality that represents this graph. Okay, so we have to look at this. We have to think, what would this line be? Okay. Well, what is its slope? It goes over 1 and up 2. No, over 2 and up 1. That's a slope of 1/2. We know the y-intercept is at 2. Okay, so what can I do for writing an inequality? Well, I could write it as an equation and say y equals 1/2 x x plus 2, like this, because it's just prettier. Okay, that works. But that's an equation. We want all of the things under this line. So we want the things, the y's that are below this line. Not the y's above this line, because this is the y-axis. We want y's that are below the line. So I want y to be less than this. So instead, I'm going to, let me just make this a little prettier. There, great, 1/2 x. And this right here, goodbye, is going to become less than, because I want the y's that are below this line. So here's the cool thing. If I plug in anything, say I plug in 5 here, well, 5 on the x-axis is going to be right here. Then what's going to happen here? Let's see. We're going to end up with 1/2 of 5 divided by 7. 1/2 of 5 is 2.5 divided plus 2 is 5.5. Y has to be less than 5.5 here. Let's see. I go to 5. Look at that, 5.5. I only want y's that are less than 5.5. Up to 5.5, but no higher. I talked, so I didn't write anything. It's okay. You get the point. We're gonna do this more. So I don't want to talk your ear off in a video where you can't even ask a question. Okay, the following table shows predicted snack sales if new pricing plan is implemented at the movie theater. Look at this. Wow. They might sell this many boxes, this number of combos for this total price. Pretty exciting stuff. They charge $7 per combo, charge $3 per box of candy. What do they make? Okay, oh, if new prices, I wondered because the prices are different. Okay, all sales above and beyond, above a certain amount each day. What? Right, an inequality that models the number of candy and combo thieves the theater can use to generate sales above this amount. Okay. Above this amount. That's really confusing. Okay, so I guess we want to sell above 14. I'm going to read between the lines. They're not being very clear with their question, actually. It's a very badly written question. But we know that they sold at least 415. Okay, so we're going to say I want to sell candies and combos and make above a certain amount, above 415 every day. Okay, so how could I say that? What is an inequality that could say that? Well, they sell candies for $3 a piece. You can see that right here, $3. They're selling combos for $7 a piece because see, they sell 45 candies at $3 a piece for $135 total. They sell 40 combos for $7 each for a total of $280. Adds up to $415 total. That's what's going on. So combos cost $7. And so all we have to do is put an X and a Y. Now I sell some candies for $3 a piece and some combos for $7 a piece, and it adds to make at least 415. But they want to make above that amount. So we're not going to say equals to, we're going to say greater than. And there, that'll work since they're being confusing. Now, they could sell 1 million of these and none of those, or 1 million of those and none of these. They don't completely depend on each other. Not completely. But if they sell a lot of one, they can't sell a lot of the other if it's going to be less than, wait, they want to sell more than, don't they? Right now, we're saying the amount they make is less than 415. I think I made a mistake. They want to sell more than $415 worth of stuff. They want our amount that we sell to be more than $415 a day. Okay. So, plot points Y on the coordinate plane. Okay, do you notice anything? Are there any sales that are more likely to happen than others? Write an inequality that represents the most likely sales of candy and combos under this pricing plan. I'm going to have to go in and look. They're being really fancy here, and it's not very clear what they want. So we're going to skip to 6 and see if that's where we're at. We are past there. It's not there. Okay, just gonna keep going. This doesn't make any sense. Skipping it. Sorry. They need to write a question that makes sense. You don't have to do it. Okay. All right. Moving on to here. Graph the solution to this. Okay, so we need to have numbers that add to make more than 6. Like 3 and 3 adds to make 6 or more. 2 and 7 adds to make 8 and 2. 5 and 17. 243 and 15. They all add to make more than 6. Okay? That's all we're dealing with here. The thing is, we just have to get used to the format of it, the way that it's being written. That's the hard part. Okay? Not the understanding that. That's all that that's asking for. So, one thing we could do is just come up with some of those. Let's figure some out. 5 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That right there, that's the 0.55. That adds to make more than 6. 6 and 6 adds to make more than 6. 6 and 5, 6 and 4 adds to make 10. 6 and 3, 4 and 5 adds to make 9. 5 and 4 adds to make 9. All of these points have x's and y's that add to make more than 6. But I can do this forever. I can just keep clicking. I can find points that add to make more than 6 for a long time. So it'd be better just to find the border. And that's why we graph these, okay? So here's what we end up doing. We find out two numbers. Let's see, if x was 6, then y would have to be 0 to add to make 6, right? So we're going to find the numbers that actually make equal 6. We're going to graph that line first. So we're going to say x plus y equals 6. Well, if x is 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, then y has to be 0. And if y is 6, 1, 2, 3, 4, 5, 6, then x has to be 0. And then we connect those dots like so. Oh, wrong button again. Get your act together. All right, like so. That borderline, everything to the left of it won't add to 6. Everything to the right of it and above adds to make 6 or more. So look, this is the point 3, 3. 3 to the right and 3 up. 3 plus 3 makes 6. 4 plus 2 makes 6. 5 plus 1 makes 6. Anything on the line adds to make 6. Anything above the line adds to make the x and the y in that point, like this point right here, is the point 4, 3. 4 plus 3 makes 7. That's more than 6. So everything up here works. Everything up here will add to make more than 6. All of the x, y combinations. You could also have down here, this is the point 1, 2, 3, 4, 5, 6, 7, 8, and negative 1. 8, negative 1. 8 and negative 1, well, that's just 8 minus 1 makes 7. That still adds to make more than 6, even though one of them is negative. So all of those points, the x plus the y, will be more than 6. All right, this one right here. This time we're going to graph the line faster. Okay, we're going to say, okay, so here's that. Okay, we have 2x plus y equals 4. So if y was 0, then x would have to be 2 times 2 makes 4, right? So that's the point 2, 0. I plug the 2 in for x, and a 0 in for y, get 2 times 2 is 4, plus 0 equals 4. Yeah, so that's a point we'll make equals 4. We always start with what equals. We always start with the line y, 2x plus y equals 4. Another thing we can do is make the other one 0. If x was 0, then we'd have 0 minus what makes negative 4, or makes 4? Well, minus a negative. So I'd have to have minus a negative 4. Okay, so I'm going to graph these 2 points. Another thing we could do is subtract 2 and divide by a negative to turn it to y equals mx plus b, but that's another story. 2, 0, it's right here. 0, negative 4 is 1, 2, 3, 4, right here. And it goes like so. That's our line. Okay, now we just have to find things where on one side or the other of it that work. So we want it to be less than 4, right? 2x minus y equals 4. Okay, So let's try making them both be 0. Will that be less than 4? Sure will. So this point works. What if x was 1 and y was 1? 2 times 1 is 2, minus 1 is 1. So that would work. So everything on this side seems to work. So we fill in on this side and we're good. We found all of the x, y things that work. I can pick another one. I can pick any point on here on random. So like this point right here. We'll pick this point right here. That's the point -2, 2. That's going to be 2 times -2 minus 2. Is that less than 4? Well, 2 times -2 is -4. Minus 2, that's -6. -6 is definitely less than 4. That's the type of math we're doing. Okay, we're just seeing that if I plug in the x and y from any of these points into this formula, it'll be less than 4. Okay? Now, to be fair, I'm being really sloppy with this right now. We don't want it to equal 4, right? So technically, the line should look like this. Okay. That means that it can't be on the line. It can't actually equal 4. It has to be less than 4. Okay, this one right here. Less than 6. Sure. Graph. If x is 0, y is 6. First, I'm going to treat this as an equals, and I'm going to graph the line. If x is 0, y is 6. If x is 0, y is 6. 1, 2, 3, 4, 5, 6. How do I know that? Because I plugged the 0 in for the x. That's going to make 0 for this whole thing. I'll have 0 plus what makes 6? 0. So first I treat it as an equal sign. And then later I'll worry about other stuff. Okay, and if y is 0, then this has to be 3. So there we go. That's our line. It's going to look like this. And notice it has an equals. It doesn't say equals, so I actually have to go like this. Again, a dotted line. Like that. Okay, now I just have to figure out which side of the line we want to fill in. We want it to be less than 6. So if I like to start with 0, 0 right here. If I plug a 0 in for each of them, is that going to be less than 6? Sure is. Technically, that's all I need. I can just, well, maybe I'll use the marker this time. I think there's a marker, right? No, that's something else, isn't it? I can, like this. Oh, it's a highlighter. There we are. Oh, weird. I haven't done this in a while. Do that, though. Whatever. That side. Everything down there will add to make negative less than 6. I promise you. Here, we're going to do the same thing. I'm going to graph 5x. Oops. 5x minus 2y equals 10. And you can plug in if x is 0, then y is -5. And if y is 0, then x is positive 2. That's what we're going to do, 0, -5, and 2, 0. Okay? I'm going to graph them in a moment. 0, negative 5 is 0, negative 1, 2, 3, 5. And 2, 0, 1, 2, 0. Okay, so we're going to have 1, 2, 3, 4, 5. This one. Okay, so there's my line. It says greater than or equal to, so I can make the line solid like this. That means it's allowed to be on the line. Things on the line will make them be equal, which is this line right here. But now I need to figure out which side of the line to fill in. So what I'm going to say is I'll use the point 0, 0. Okay, 0, 0. If I plug a 0 in here, a 0 in there, I'm going to get 0 minus 0 is greater than negative 10. Is 0 greater than negative 10? Yeah, it is. So that's the side I'm going to fill in. And I'm going to do it with regular pen this time. The other thing didn't work. So this is the side. No matter what point I pick on this side, I can pick any point at all, ever, anywhere over here. And the two numbers, if I plug them in, it'll be greater than negative 10. And that's the trick. Okay. I think I'm almost done. Last page. Let's graph this solution. 3x plus 2y is greater than 6. Now first we have to graph it. And then we have to fill in the side that we want to fill in. So we're going to go like so. Here's our graph. Here's our other graph. If x is 0, y is 3. If x is 0, y is 3. If y is 0, x is 2. And there we go. Those are our 2 points that I used to graph. I graphed those 2 points. And then I can just go here, make this be 2 again. And I'm going to go over 2 and up 3. So something like that. I know it's not perfectly straight, but the world isn't perfect. Sorry. And now I'm going to ask 0, 0. Does 0, 0 work in this? Because if 0, 0 works, then I'm going to fill in the side with 0, 0. If 0, 0 does not work, then it's not. It doesn't work. So if I put a 0 in here, it makes 0. 0 in here makes 0. Is 0 plus 0 bigger than 6? No, it's not. So that means it's got to be the side of the line that doesn't have 0, 0. That's the process we go about. So any point over here, let's try this one right here. This is the point 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 7, 6. Right? We're going to check 7, 6 just to remind you how it works. 3 times 7 plus 2 times 6. The question is that greater than 6? Well, 3 times 7 is 21, plus 2 times 6 is 12. Is that greater than 6? Better be. Yes. This is a solution because 21 plus 12 is 33. Is definitely greater than 6. So we did it right. I should technically change all of these to greater than or equal still. Okay, last problem. Reinforce. One morning you wake up and you realize that you have overslept test day. Oh no! You only have a certain amount of time to complete the test, which is made up of multiple choice questions and essay questions. The following table gives you some of the combinations that you could use. Okay, sure. We have time spent on writing an inequality that models the combination of multiple choice and essay questions you could answer during the test without running out of time. Okay, so how much time do we have for the test? Following table gives combinations. I guess that 90, I don't know. Ugh, okay. So we have a number of multiple choice questions. You could do 60 multiple choice and no essay questions, and it would take 60 minutes because each multiple choice seems to take 1 minute. Or you could do 60 of these and 15 of those, or sorry, and one essay question. Essay question takes 15 minutes. Looks like we can't go over 90 minutes though, can we? Right? So we're going to say, we are going to assume that based on what they've said, multiple choice plus essay is less than or equal to, or at the very most, 90 minutes. It can't be more than 90 minutes. 90 minutes, we run out of time, right? Okay, so how do I talk about that multiple choice that I need? I would say you need to say, well, multiple choice take a minute each, right? So we'll say 1 minute times the number of multiple choice questions plus 15 minutes times the number of, I would use X and Y. E, I don't like using E, and M looks like minutes. Is less than or equal to 90. So I'll just go. That's what we're looking for. So you could do one of each, and you'd have plenty of time left over when you quit. You could do two of each. But when you get to a certain point, these two things can't add to make more than 90 minutes. And that's how we get a limit on what we're doing. So you couldn't do more than 6 essay questions because you wouldn't have any time left. And you couldn't do any more than 90 multiple choice. Of course, whoever wanted to do a 90 question multiple choice problem, the test would be dying. Point is, this is the thing. Hopefully that makes sense. The number of multiple choices plus the number of essay questions at 1 minute per multiple choice, 15 minutes per essay question has to be less than 90 minutes. Okay, that's it. We have finished Unit 8. I'll try to explain things better in the future.